We may as well relax and be comfortable about this. But don't forget, there's a lot to learn. Now we come to about the most important thing you men will have to learn. The adjustment of a new pack saddle. Bring in that new saddle we picked up. You see, each saddle you put on a horse has to be adjusted to that particular horse's back. It can't be used on any other horse without complete readjustment. Now, the foot of a saddle is as important to a horse as the foot of a shoe is to a soldier. These pack saddles are made so that very little adjustments are necessary on a normal horse. However, this weight-bearing surface of the saddle has to conform perfectly with this, the weight-bearing surface of the horse's back. Is that clear?
This mathematical weight compensation formula can calculate the effect of gravitational forces due to the pack load on the shape of the animal's back, which directly affects the fit of the saddle. This is a simple animation that explains how this measurement system works. This slide provides an orientation with a side and top view of the animal and the relative position of the saddle panel or bars in relationship to the animal's back. The goal of proper saddle fitting is to achieve even weight distribution when the saddle is loaded with either the rider or the pack load. The goal is not to have even pressure when the animal is moving, because that is impossible, because the animal's back moves to a small degree with the legs. However, we can achieve healthy, uneven pressure distribution when the animal is moving if we can achieve even pressure when the animal is measured static. That requires accurate measurement. Unfortunately, because the rock or arc in the saddle is less than the arc of the animal's back, what we usually achieve is uneven high pressure when the animal is measured statically, which does not go away when the animal begins to move, because the 4 points never permit the back to contact the animal in the middle of the panel to permit the pressure to be relieved. To address the saddle fitting issues, we need to think of saddle fitting as a balance between the weight of the load relative to the weight of the animal. Now, if you put 25 pounds on an animal's back, nothing's going to happen. The weights and numbers are purely for illustration to present a concept. The whole point of the formula is to be able to balance the equation by using the numbers. If you add another 25 pounds for a total of 50 pounds on the animal, not much is going to happen because it is still a small fraction of the animal's weight. Now, if you put an additional 25 pounds on the animal for a total of 75 pounds, things will begin to change. Now, if you add yet another 25 pounds for a total of 100 pounds, you will reach a balance point, such as the proverbial straw that broke the camel's back. From here on out, each increment of weight will have a measurable effect on the shape of the animal's back. Now, if you add yet another additional 25 pounds to the load, the animal's back will sag a measurable amount, which is the reason that fitting the saddle to the unloaded animal will cause the saddle to bridge or not to fit. Now, I use 1 degree for illustration only. The whole point of the formula is to calibrate this effect on
How
the
many
animal's
saddles are
back.
sold?
The method of description that has proven to be overwhelmingly superior is mathematics. So we want to define the relationship between the various weights mathematically. The weight compensation factor equals LW, which is the load weight, minus C. C equals the balance weight that will not cause any change in the shape of the animal's back, divided by B, which is the incremental greater weight that will cause the animal's back to sag a measurable amount. Now, this formula is a balance between the weight of the load relative to the weight of the animal, so we need to add the animal's weight to this equation. Mathematically, that is done by adding Z, which equals the weight of the animal that will not cause the animal's back to change, minus the animal's weight, divided by Y, which is the incremental greater weight that will cause the animal's back to sag a measurable amount. The relationship of the weights are inverted, so that the ratio is balanced. Core fit is measurable. This amount can actually be accurately measured with a gauge that defines the polyform shape of the animal's back into angles and arcs. By measuring the animal and applying the weight compensation formula to the wither and loin arcs, the difference between the unloaded animal's back shape and the loaded animal's back shape can be precisely defined. And with the use of an interface pressure measurement device, this formula can be calibrated precisely. Now, if you reduce the size of the animal or change species, that balance will change because the relative difference between the animal's weight and the load will become greater. But that difference can be measured and calculated. Alternatively, you can adjust the shape of the saddle or choose another saddle to fit the shape of the animal's back with the load in place. Measurement permits the process to be controlled. You can also lighten the load so that the difference between the animal's weight and the load is decreased. But again, the whole point is to have a formula that permits the amount of proper load to be calculated. You can also increase the size of the animal or use a different species or an animal that is in better condition. Using this formula, a matrix can be established to define the fit of various species, similar to an artillery trajectory table. But the crucial point is that all of these variables can be defined, calculated, and validated employing the saddle fitting method offered in this unsolicited proposal. Here is the same calculation in a graph form that is a little easier to understand. We just determine the animal's weight, follow that line down to above the corresponding weight of the load, and follow that line across to the degree of adjustment we apply to the arc of the saddle tech gauge, which is then applied to the shape of the pack saddle. It's really pretty simple. You do not need to be a saddle fitter, you just need a saddle tech gauge. This is not rocket science, which is why this technology has great utility in military operations in third world countries, because with minimal training, anyone can do this. Employing both instruments permits an evidence-based method to fit a saddle to an animal. The key to the greater accuracy is the feedback loop, which is also called the scientific method. There are no companies in the world competing at this level of animal and saddle measurement technology. This is how the scientific method can be adapted to saddle fitting. 1. Measure. Observe some aspect of the universe. Gauge measurement. 2. Hypothesis. Invent a mathematical relationship called a hypothesis, the weight compensation formula. 3. Predict. Use the hypothesis to make predictions, the weight compensation factor. 4. Test. Test those predictions by experiments, computer interface pressure mapping. 5. Validate. Repeat steps 3 and 4 until there are no discrepancies, formula calibration. This method of saddle measurement would permit an appendix saddle fitting military specification to be written.
Now, the foot of a saddle is as important to a horse as the foot of a shoe is to a soldier.